Amazing. As it relates to AI, do you think that young people and older people now, I'm 49, so I put myself in the older bracket, should be learning how to use AI?
They are already learning how to use AI. And again, it's just like new technology comes along, who picks it up first? It's the younger people. And it's astonishing. They're using it a lot more than I use it almost every day, but I know a lot of students who basically, and by the way, it's like any other tool. It's a tool that you need to know how to use it.
Where do you suggest people start? I have started using Claude AI.
Okay.
This was suggested to me by somebody expert in AI as an alternative to ChatGPT. I don't have anything against ChatGPT, but I'll tell you, I really like the aesthetic of Claude AI. It's a bit of a softer beige aesthetic. It feels Apple-like. I like the Apple brand. And it gives me answers. Maybe it's the font, maybe it's the feel. Maybe this goes back to the example used earlier where I like Claude AI and I'm a big fan of it, and they don't pay me to say this. I have never met them. I have no relationship to them, except that it gives me answers in a bullet-pointed format that feels very aesthetically easy to transfer that information into my brain or onto a page. So I like Claude AI. Use ChatGPT. How should people start to explore AI for sake of getting smarter, learning knowledge just for the sake of knowledge, having fun with it? What's the best way to do that?
I think exactly what you did, which is there's now dozens and dozens of different chatbots out there, and different people will feel comfortable with one or the other. ChatGPT is the first, so that's why it's taken over a lot of the cognitive space, right? It's become like Kleenex, right? That word. That was why I used it as the first word in my new book, because it's iconic. But some of them, I have to say that, for example, there's some that are really much better at math than others.
Such as?
Google's Gemini recently did some fine-tuning with what's called chain of reasoning. In other words, when you reason, you go through a sequence of steps. And when you solve a math problem, you go through a sequence of steps of first finding out what's missing and then adding that. And it went from 20% correct to 80%, right, on those problems.
And as people hear that, they probably think, well, that means 20% wrong still. But could you imagine any human or panel of humans behind a wall where if you asked it a question and then another question and another question, that it would give you back better than 80% accurate information in a matter of seconds?
So I think we are being perhaps a little bit unfair to compare these large language models to the best humans rather than the average human, right? Mm-hmm. As you said, most people couldn't pass the LSAT, the law test to get into law school, or MCAT, the test to get into medical school, and ChatGPT has.
Is there a world now where we take the existing AI, LLMs, these computers basically that can learn like a collection of human brains and send that somehow into the future, right? Give them an imagined future, okay? Could we give them outcome A and outcome B and let them forage into future states that we are not yet able to get to, and then harness that knowledge and explore the two different outcomes? I think that's perhaps the better question in some sense, because we can't travel back in time. But we can perhaps travel into the future with AI if you provide it different scenarios and you say, unlike a panel of people, panel of experts, medical experts or space travel experts or sea travel experts, you can't say, hey, you know what, don't sleep tonight. You're just going to work for the next 48 hours. In fact, you're going to work for the next 3 weeks or 3 months. And you know what? You're not going to do anything else. You're not going to pay attention to your health. You're not going to do anything else. But you can take a large language model and you can say, just forage for knowledge under the following different scenarios, and then have that fleet of large language models come back and give us the information like, I don't know, tomorrow.
Okay, so I've lived through this myself. Back in the 1980s, I was just starting my career, and I was one of the pioneers in developing learning algorithms for neural network models. Jeff Hinton and I collaborated together on something called the Boltzmann machine, and he actually won a Nobel Prize for this recently.
Yeah, just this year.
Yeah, he's one of my best friends. Brilliant, and he did that, well deserved it for not just the Boltzmann machine, but all the work he's done since then on machine learning and then back propagation and so forth. But back then, Jeff and I had this view of the future. AI was dominated by symbol processing, rules, logic, right? Writing computer programs. For every problem, you need a different computer program. And it was very human resource intensive to write programs, so that it was very slow going. And they never actually got there. They never wrote a program for vision, for example, even though the computer vision community really worked hard for a long time. We had this view of the future. We had this view that nature had solved these problems, and there's existence proof that you can solve the vision problem. Look, every animal can see, even insects, right? Come on. Let's figure out how they did it. Maybe we can help by following up on nature. We can actually, again, going back to algorithms, I was telling you. And so in the case of the brain, what makes it different from a digital computers basically can run any program, but a fly brain, for example, only runs the program that its special purpose hardware allows it to run.
Not much neuroplasticity.